Okay, we are recording. Good afternoon, good morning, wherever you're seeing this video. Today we're gonna do a pattern and nestion tutorial where we're gonna make a parasolid example, a parasolid solid example. And the objectives of this example is to learn some of the steps that you can use to create a B-rep solid, extrude surface, make shell, and edge blend, then create an infinite element model, analyze the model, and post-process the results from the analysis. The software that we're using is Pattern Standard Edition, as you can see. Okay, for starting this, we're gonna have to create a new file. We're gonna go to File, New, search for a folder to save the file. We're gonna do it in this one, and we're gonna name this activity as tension fitting. Okay, we're gonna click OK, and then we can start our activity. Here we have to make sure that intolerances is selected base model. Here number 10 in approximate maximum model is dimension and analysis code MSC Nastran and analysis type structural. We're gonna click OK and we're gonna start our model. First we're gonna go to geometry. We're gonna create the surface with the X, Y, and Z axis. We're gonna put in vector coordinates these numbers 5 space 2 space 0 with an origin coordinate list of 0 space 0 space 0. We're gonna create our surface and it has to look like something like this. Okay, now we're gonna add some points so we can create later our solid. So make sure that you can see the points. We're gonna make our points bigger. We have to go to home, and here we gonna click in point size so you can see our points. We're gonna still be in now in geometry, and still we're gonna make in transform, point, and translate. First, we're gonna enter in our direction vector. Here in the direction vector, in transition vector, we're gonna apply a 0.5. We're gonna leave our 0 instead of the other 0 for the other axis, and we gotta apply it. Okay, always put on click auto execute so you don't have any problems with this. We're gonna hit in our point list. We're gonna erase this and select our left up corner. We're gonna hit apply, and we're gonna make this point. Okay, now we're gonna erase our direction vector and add a different one. When we put a 0 space 0.5, so we do create our next point. We're gonna select the right down corner and we're gonna hit apply. And then now we have our 2 points so we can make our solid. Next, we're gonna keep in geometry. We're gonna make a curve. We're gonna select point. Oh, sorry. Create curve and point. The starting point and our ending point are gonna be the ones that we just made. Gonna select our starting point. I'll always turn off auto execute. And our ending point, we're gonna hit apply. And then we're gonna eliminate these lines or curves so we can create our solid. But first we have to go to edit here in geometry, surface, and break. Yep. We're gonna turn auto execute off. Our surface list is gonna be the one that we first made, and the break curve list is gonna be the curve that we just made. So okay, and this message is gonna appear, and you're gonna put in yes. Okay, now we're gonna go to home and refresh our graphics. And now it's gonna this the surface that we just made is now has recap into two different surfaces. So now that we can eliminate the surface that we don't need. When you go to delete surface and select the surface that we don't need, that is this one, the top one. Eliminate it, and we are done with this surface. Now we have the basic structure of our solid. We're gonna create our solid. We're gonna stay here in geometry. We're gonna create a solid and extrude. Okay, we must have this one turned on in test measurable. We're gonna enter in our translation vector 0 space 0 space 2. We're gonna select always turn off auto execute. We're gonna select the surface. Now you can see that the other surface is gone, and we're gonna hit apply. Now you see we have now our solid. For a better view, you can turn on smooth shaded, so you can see the solid. And also always to keep a reference from your image, always click on ISO 1. Yeah, ISO 1 view, so you can see it like pretty good. Okay, now we're gonna make the shell. We're gonna stay here in geometry. We're gonna hit on edit, solid, and shell. We're gonna put on a thickness of okay here, yeah, 0.25. Turn off auto execute, and we're gonna select the faces that we want to make, where we want to make the shell. We gonna click this button that is add to selection, so we can add all faces at once. We select these three faces, and now we're gonna hit apply, and you can see that we made our shell. Hit ISO 1 so we can okay. Now we're gonna create the fillets. We're gonna stay here in edit and solid also, and edge blend, so we can create this our type of fillings. We're gonna select constant radius, and our radius is gonna be of 0.25. Edges of solid has to be it has to be selected, and also turn off auto execute. Click on the plus sign again so we can select multiple lines, and we're gonna select 5 lines to make this fillets. We're gonna select this line, the other line in the inside. Just make sure that you're selecting the right line. Okay, this is kind of tricky. This line also, this line, and this has to be okay. Sorry, I make a mistake. To have a better view, I'm gonna select wireframe, so we can see the lines that we have to select is this line. Just move it a little. This line, this line. We have 3, 4, and 5. 5 lines. We're gonna turn on again the solid view. We're gonna hit apply, and we can see that we are ready to make our fillets where we want to. Now we're going to create the holes to create the tension fitting in this object. We're gonna go to create, still in geometry, create. We're gonna create a solid and primitive. We're gonna select cylinder to make our hole. We are gonna enter a height of 2.0, a radius of 0.25. We're gonna leave the thickness list on zeros. And here on reference coordinates, leave it in coordinate 0. We're gonna we wanna put where our base center point is gonna be. It's gonna be in this face. And we're gonna put the center point, which is -1 space 1.25 space 1. And the axis list, we're gonna put coordinate 0.1. We're gonna hit apply. We can see that now we made our solid. Now we're gonna go to in edit so we can delete or make our hole. Edit and solid and boolean. We're gonna select subtract. We're gonna select our target solid, which is the solid that we just made. No, sorry, is the solid that the first solid we made, and the subtracting solid is gonna be the one that we just made. You're gonna hit apply, and now we can see that we have a hole. Okay, now for creating the other holes for the tension fitting, so we can see other stuff. We're gonna create other holes, but since we don't have points to create those solids, we have to create some points. We're gonna return to our wireframe view so we can make our points easier. We're gonna hit in transform, still in geometry, transform, point, and translate. Translate, yeah. First, we're gonna make a translation vector. We're gonna hit 0.0 point, okay, minus 0.5, and we're gonna select this point, which is in the always turn auto execute off. We're gonna leave everything else as it is. And we're gonna select this point so we can make a point right about here in the middle. You're gonna hit apply. Now we see that we made our point. Now we're gonna make other points. First, we're gonna put 0, okay, minus 0.75 and 0 space 0. We're gonna select the point that we just made in the point list. And we're gonna make this point, hit apply. See, now we have this point. And now we're gonna make other points. I'm gonna select this point since the beginning, and we're gonna change our direction vector to 1.5, 1.5 to be more exact. And we're gonna make a repeated point. So here in repeat count, we're gonna put number 2. We're gonna hit apply, and now we have more points. Now that we have our points, now we can make as the step in the last point, we're gonna make the same. We're gonna make some solids. So we stay here in geometry, and we're gonna put and create solid and primitive. Still, we're gonna choose to make cylinders. Okay, in high list, we're gonna put -1. In radius list, 0. Sorry for that, 0.125. And the points that we're gonna use are gonna be here in base center point list, where the points are gonna be. Where are we're gonna hit this plus so we can select multiple points. This one, the points that we just made, and we're gonna enter in axis list 2 so we can make the solids look down. We're gonna hit apply, and if we change our view, now we can see that we made our solids. Now, as the same as the step before, we're gonna select edit solid and boolean. Also we're gonna select subtract. The target solid is still gonna be the main body, and the subtracting list, we're gonna select the 3 objects that we made. We're gonna hit apply, and now we have holes. Okay, now we're gonna create a cylinder to imprint tension fitting. This is where our forces are gonna be applied. Okay, we're gonna change to our wireframe view so we can have a better view of what we're doing. We're gonna go to create point in arc center, so we create our tension fitting that is gonna be in this part. So we turn off auto execute, we select our curveless, which is gonna be this circle. We're gonna hit apply, and we can see we made a point in the middle of in this circle. Okay. Now that we made that, we're gonna create again a solid. Still, we're gonna use cylinder. In height, we're gonna put 0.1. In radius list, we're gonna put 0.371. And coordinate 0.1. And the base point we're gonna use is the point we just made. And hit apply. And now as you can see, we made this solid. Now to make the imprint of the solid, that we need to make the forces hit in this face, we're gonna hit edit, still in geometry, edit, solid, and imprint. The solid A, this is the solid that we just made, and the imprint we want to make is gonna be the solid that we made for this thing. Always turn auto execute off. As you can see in this part, the imprint is already been made because I didn't turn off auto execute. And if I put apply, I will have made 2 imprints. So this is something we want to avoid. Always turn auto execute off before you hit any stuff. Okay, we already made our solid imprint. So now we're gonna have to delete our imprint, our solid we made. We're gonna go to delete, solid, select this one, solid number 2, as it says. Always turn auto execute off and apply. Now it's deleted. But as you can see in the wireframe, you can see the circle, which is where the forces are gonna go. Now we gotta mesh our solid. We're gonna go in meshing, create, mesh, solid. We're gonna select TET match, and TET 10 as our element, measure, and topology type. Here in input list, we're gonna select our solid, and we're gonna turn off automatic calculation. The lower the value you add, the more triangles are gonna be made in the mesh. I'm gonna put 0.5 since I am using a student edition, or my 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 student edition of Patreon cannot handle many triangles since it's a standard edition. If you use a lower value like 0.25, it's gonna go better, but I have to use higher values so my software do not crash. We're gonna hit apply. We can see that our mesh is made. And now the next step is to create our loads. Loads and constraints. We're gonna go to loads and create total element, total load, excuse me, and element uniform. This one. We're gonna enter our new set name of the force, which is gonna be a force. We're gonna select input data. This window is gonna appear. In the loads, we're gonna apply a minus 5,000, a comma space 0, 0. Also other values. We're gonna click OK. We're gonna select application region. And we're gonna select the imprint that we just made. So to say solid 1.1. If you made our the same values as we just made, you're gonna add it. Gonna hit OK and then apply. Okay, as you see in this one, the mesh that I just made, it was a little bit too, the value was a little bit too low, and since I using a student edition, I have to change that mesh to be smaller. But as you can see now, the values of the force are made. I'm gonna go to meshing, change the value, I don't know, to a bigger number. I'm gonna put 75, and let's see if we can use that one. Seems to be yes. And our mesh is done. Okay. We're gonna keep to the next steps. Now we're gonna create our constraints. That's why we made these holes. These holes are the constraints of this piece. We're gonna go to loads. We're gonna make create displacement and nodal. We're gonna write our new name as fixed. In input data, we're gonna put in translation 0, 0, 0. We're gonna hit OK. In selected application regions, we're gonna select our 3 holes. We have to select this surface or face, so we are able to select only our holes. So we're gonna select this hole. Excuse me. This hole, and okay, it's kind of tricky. I only want to select this hole. Come on, come on. Okay, now we're gonna select our 3 holes, 1.22, 1.23, and 1.24. We're gonna add those. Click OK, and hit apply. As you can see, we have now our constraint vectors are on point. And our PS must look something like this at this point. Now we're gonna create our material properties. We're gonna hit properties, isotropic, and manual input. We're gonna create a material name, which is gonna be in this case aluminum. Aluminum. We're gonna hit input properties. This window is gonna appear. We're gonna select an elastic modulus of 10 to the 6th, 10e to the 6th. From elastic modulus, a Poisson ratio of 0.3. We're gonna hit OK and apply. Okay, now their material is made. We're gonna select 3D element properties. We're gonna still be on properties. We're gonna choose 3D and solid. In this here we see 3D and properties. Here we're gonna click in solid. Now we're gonna put our property set name. We're gonna name this one 3D TETS. We're gonna go to input properties. This window is gonna appear. We're gonna select the material we just made, which is aluminum. Now that we select our aluminum, you're gonna click OK. For applicational region, we're gonna select our entire body. We're gonna hit add and OK and apply. You can see this now made 3D tests. Okay, now just to check if the loads case default, just to make sure that the loads and constraints are selected, we're gonna go to load cases. We're gonna select modify. Where is this? Yeah. We're gonna select this button. Okay, create load cases. We're gonna hit modify. We're gonna select default, and this window is gonna appear, which is gonna show us is our displacement and total load is made. Which is this one, fixed and force. You're gonna hit OK and cancel. We're not gonna make anything here now, just to make sure. Now we have to run the analysis in MCC Nastran. We're gonna hit in analysis, entire model, full run. You're gonna click on translation parameters. This window is gonna appear. You're gonna make sure that the solution, that XDB and print is selected. You're gonna hit in subcases. Direct, no, sorry, is in output. Oh yeah. Sorry for that. I was looking for this one. Just move. I don't know why. Okay, we're gonna click in solution type, solution parameters, request output format. We're gonna select XDB and print. We're gonna turn off HD5. Well, we're gonna leave it. This is our buffer size. We're gonna hit OK. Make sure this, okay, OK, and OK. Here in our solution type is gonna be checked linear statistic. I'm gonna click OK, and it seems like everything is okay. We're gonna hit apply. This window is gonna appear. which says that Nastran is running. Okay, now that Nastran is ready to run, we are gonna uh, access our results. We're gonna go to analysis, access results, XDB, and result entities. We're gonna select our tension fitting, which is our available job that we just made. We're gonna hit OK. Yeah, select result files, which is one tension fitting, which is our only one. I'm gonna hit apply. Now we're gonna go to results, and we're gonna create to see the deformation in our solid body. We're gonna select the default A1 statistic subcase under selected result cases, which is this one. We're gonna select displacement translational. Sorry, in displacement translational as our deformation result, and we're gonna hit apply. Now we see the deformation our body just have. This must look something like this. If you have used a bigger type in the meshing, if you use a higher value of the mesh, the how it works is gonna be a little different because the system will think different things, and this result is gonna look really different. So if you use a higher mesh, it's gonna take a little bit more time. It's gonna be a heavier file, but it's gonna have better results, more accurate results. Okay, now we're going to continue. We're gonna choose here in display, plot and erase. We're gonna hit erase in geometry. Gonna hit OK. Now we're gonna click on display attributes. In this one, here in still in creating information in our results slide, we're gonna show undeformed, which is what is it? Display attributes. We're gonna remove the check from show undeformed. We're gonna unclick this one. Our render style is gonna be shaded, and we're gonna click apply, so we can see the deformation of our solid, how it will look with that force that we applied, and how it look all deformed. Okay, to see the parts where it have more deformation. To see the von Mises stress model, we're gonna go to here in results and still in create fringe. We're gonna select stress tensor. Where is it? Stress tensor. Here is the last one. Almost the last one. Yes, sure. The last one. Stress tensor. Here in quantity is gonna be von Mises. Now we're gonna select. Sorry. Stress tensor. Von Mises. Here we're gonna select element edges in display. We're gonna hit apply. Now we can see the parts where the stresses are the highest, which must look something like this. Here we're gonna have some stresses in this part, which are the closest and the farthest. The stresses in the part where the forces are bigger. You have a scale of how the stress is, the number of stress, the value of the stress. Okay, and that's all. That's all that is for this practice. Okay, and thank you for seeing this tutorial, and see you in a next tutorial. Subscribe to the channel, hit like, and have a good day.